Hi, everyone. Welcome to SUSECON Digital 2021. I'm Brian Six with SUSE. And the session here is TUT 1102, Apply Security to Your Servers or Containers with AppArmor. AppArmor, by the way, is included with SUSE Linux Enterprise Server subscriptions. So it's already available to you to utilize. So let's dive in, let's take a look, and let's see what you can do with AppArmor. From an agenda perspective, we're going to do a little introduction to AppArmor, talk to you a little bit about what it is and what it does. And then we're going to look at how do we configure and test AppArmor? What are the utilities that are available to us? And then let's dive in. Let's do some hands-on. Let's play around with it and kind of dig our teeth in and kind of show you how AppArmor works. And then we'll come back, take a step back and look at, well, what about container support? In this new world of application delivery with Kubernetes and containers, how can AppArmor help us in that environment? So let's start off here. First off, what is AppArmor? AppArmor is it's a Linux security module, or it plugs in at the Linux security module layer. Now, this Linux security module was a framework that was created, and it was built for applications such as AppArmor to be able to plug in and apply and employ certain security functions that would not require adaptations to the kernel or modifying the kernel or even applying another security layer on top of the kernel. So this allows you to plug directly into an existing infrastructure. And it is considered a mandatory access control security system as opposed to a discretionary access control security system. Discretionary systems typically rely on the identity of a user or the properties of a file or an attribute of a file or a directory somewhere to determine what the security application should be. Mandatory access control systems look at, and in our case, AppArmor, looks at a profile irrespective of the user or the directory. So this gets rid of the opportunity for malicious software or malicious attacks from hackers from being able to leverage a vulnerability in an application and perhaps what elevated privileges that application has, and then execute with that to perform bad things on your servers. And so AppArmor plugs in, again, at the Linux security module layer as a mandatory access control security system so that users and personalities and things like that can't get around this particular layer. And it's dynamic for all the profiles that are established at the time a server is booted or AppArmor happens to be reloaded. And this is essential to know when you're dealing with profiles against existing workloads that are running, because you can make modifications to those profiles and not affect the applications themselves, and everything is acted upon real time. So in this screen, I kind of want to give you an architecture slide to show you where AppArmor plugs in. Again, it plugs in at that Linux security module layer, and this provides you efficiencies and optimizations that you would not get if it was built any other way. So what does AppArmor do? Let's take a look at this. Well, first of all, AppArmor leverages a wizard-based approach to track what an application's activities are and then builds a profile around those actions. So it's very easy to enable these profiles and build them if you choose to build them from scratch, whereas you can also download them from the internet and from other places. And in fact, when your SUSE Linux Enterprise server is built, we will ship with a number of profiles already installed and in enforced mode when the server is built. Now, what's interesting to know about this approach is that when the wizard helps you build this profile, it helps you determine what an application is allowed to do. The other side of that is AppArmor will block that application from doing anything that wasn't in that original scan. So it will restrict access to files and paths and even network functions that aren't in that original profile. So it enforces good application behavior in doing that. And AppArmor can be run in what we would call enforce mode or in complain mode. Enforce mode, as it sounds, enforces the policy for the application that it's related to. Complain mode allows you to allow an application to function normally and record in a log file, if you will, all of the activities so that AppArmor isn't necessarily blocking the activities, but it is allowing them to function so that it can learn more about what an application is doing. Now, when you're building one of these profiles from scratch, then the entire application's profile is empty, and therefore everything is recorded in complain mode because you're starting from scratch. But had you built this profile a version ago and now there is an update, in order to capture what might be new functions and features that that application could exercise, you would put the application or AppArmor into complain mode for that profile, learn what these new functions and features would be, and then save that profile and then reestablish the enforce mode that you had earlier. So how do we configure and test and play with AppArmor? Well, first of all, you have to install or make sure that the AppArmor utils packages are installed on your server. Now again, SUSE Linux Enterprise Server comes with AppArmor enabled, and the AppArmor utils are already installed. But if you're leveraging AppArmor, for example, on a different distribution, then you may find that the AppArmor utilities aren't available, and therefore you must install them. But once they're installed, down below, you will see all the various utilities that come in that AppArmor utils package. Now, some of the more common ones, the ones that you will use on an everyday basis, are listed here. First off is the AA status utility. Tells you a little bit about all the policies and their enforcement status. The AA genprof is a utility that helps you create a profile from scratch. And the AA logprof helps you update an existing profile. Again, in that sort of mode where you've got an update to an application, or maybe when you did the initial profile capture with the wizard, you did not exercise all the functions within an application. And you may find that there are users who are complaining and expressing the frustration with an application because it's not acting right. You can leverage the log profile to modify and maintain these AppArmor profiles as time goes by. And then we have here the last two, AA complain and AA enforce, basically putting a policy or a profile into complain mode or into enforce mode. So enough with the presentation side of things. Let's dive in and take a look at AppArmor, and let's do this hands-on. So I've got two windows open here to my server, and you'll understand why here in just a second. And I have my AppArmor utilities already installed. So if I do AA tab, you'll see that there are several of those utilities here. AA status, as we described earlier, tells me a little bit about the state of AppArmor and the profiles on my particular system. Here you can see, and I want to go through this because it's important to take a look at this to help understand what we're looking at here. You can see that there are 48 profiles loaded and 48 profiles in enforce mode. And listed below here are those 48 profiles. Now, this does not mean that I actually have these particular applications or processes running, although I may. It's really just telling me that these profiles are loaded whether I've got the application or processes running or not. Now, down below, you'll see that there are 0 profiles in complain mode, but that there is one process that has been defined with a profile, and that one process is in enforce mode, and it lists to me what process that is. So it's kind of handy. It tells you almost everything you need to know about the state and status of AppArmor on your particular system. Now, the profiles that I mentioned that are already loaded, the ones you see here that are in enforce mode, are stored in a directory under etc called AppArmor.d. And there are the other profiles. And I'd like to point out that when you look at the names, the naming convention of these profiles, for example, the Apache 2 profile here, notice the naming convention user.sbin.apache. Sounds similar to a path name. Well, in fact, it is the path name. The name of the profile here is actually the path to the file or the application or process to which it is being applied. But we substituted the slashes in the path variable here from /user/sbin/apache2 to user.sbin.apache2. So that naming convention will just help you know to which application is that profile being applied against. So let me just clear my screen. Now, I've got an application here that I've created, and it's really just a script called aatest.sh. And this is a very simple script that just simply tries to write a file and delete a file and download some files. And so it executes several different functions that may be part of a typical application. And so if I run AATest just as it is, there's no profile for AppArmor created or anything like that yet. If I run AATest, you'll see that it tries to create a file, then comes back and tells me it created one successfully. It tries to then turn around and remove that file. So it executes sort of a, can I create a file and can I remove one? And then can I run wget to download a file successfully and then remove that to clean it all up? And of course, my application runs as it should. But if we would like to apply an AppArmor profile to this particular application, then we would want to run the aagenprof command, and we would want to pass to it as a parameter the path to the application, in my case, my script, that I would like to build a profile for. Now, I'm going to specify the full path. Although you might, if you forget and just specify the actual application name, it'll try to determine what the full path is and create the profile for that with the appropriate naming convention. But I like to put in the full path just to take out any of those variables. So when you run aagenprof against this particular application, it comes back and tells you, great, I'm going to profile this particular app. And then it says, please go start that application in another window, hence the reason I have that second window, and execute all the functions of that particular application. So let's go do that. Let's go to my other window, and let's go run that aatest.sh script and have it execute again all of its actions or activities successfully. And again, I'm not applying a profile yet, I'm just building one. So my application's fully capable of doing all the things that the application is allowed to do. So it's created its file, it's deleted the file, it downloaded, and it downloaded the file, then it removed that particular file that was downloaded. So it cleaned itself up. So I've executed my application, and then I come back, and the AppArmor wizard, aagenprof, is telling me that I can hit S to scan the system log for all those AppArmor events, all the activities of my application, or I can hit finish if I've already done that and exit the wizard. Well, I want to hit S for scan, And it's going to go through that log file, read that log file, and then prompt me for all the different activities. Now, there are several different options that I can pick and choose from all down the line here. And I'm going to choose inherit because that's the one that's going to work for me in this particular case. There's great documentation, by the way, to learn about what those other options are. But I'm going to press inherit to allow access to execute. Notice it's trying to tell me that it's trying to execute the TUT command, and I use that inside my script. So I hit inherit for that, and it asks me about sleep, and I'll say, sure, let's do that one. And I use touch to create the file, so let's inherit that. And then I use RM to remove the file, and then there's my wget. So again, I'm just pressing inherit to say, allow these particular things to run. And then it switches over. Now it's not giving me the inherit option anymore. I'm getting more of an allow deny kind of operation here. And it's giving me choices, a number 1 or a number 2. And I can use the arrow keys to upload or up arrow and down arrow to choose either 1 or 2. And it highlights the one that's suggested. So I'm going to leave the suggested one sort of highlighted there. And I'm going to hit allow because I want everything, since my application was functioning properly, I want to allow all of those activities to occur. So I'm going to hit allow for that one and hit A for that one and allow for that and allow for that and allow for that and allow again. And then it's completed analyzing the log file. So it's understood now all the activities of my quote unquote application. So it says, here are some choices for you. And I'm going to hit S to save because I want to save the changes to my profile. And now it's back to, should I scan or should I finish? And I'm going to hit finish. At this point, if I run AA status again, you'll notice that at the top, I have my /root/AA test script, and it's enabled and it's in force mode. And it's a very simple script, and the profile for it is also pretty simple. Let's take a look at it. And remember the path, the name of the profile is the path, so it's root dot AA test.sh. Did I spell that wrong? Or no, sorry, not in /root AppArmor-D. How about /etcd AppArmor-D? My bad there. Etsy/AppArmor.d. And so there is my profile. And it's pretty simple, pretty straightforward. And if you were to just look at this as you might be doing and not knowing much about it, you can see some of the syntax is pretty simple. Some of the values are probably and does stand for read, write, and write. Read, write, and lock, I think, for K. So there are certainly values in here that we'll go in and take a look at in a second to see what some of the more common variables are for this. But this is my profile, and it's in effect. So if I were to come back and try to run my application, I would expect that it would run because I haven't changed anything. The profile is in effect, but it should be allowing my application to do everything that it's supposed to do. So if I run AA test again, it tries to create the file, does so successfully. It's going to try and delete it as before, and it should do that successfully. And then it should try and download with wget, and all of that should be successful. Great, no worries. Now, one thing I want to call attention to is you'll notice in both cases, from the red highlighted text, I'm logged in as the root user. So there's really nothing that I should not be able to do from within this server, even though I've got AppArmor loaded, I'm logged in as a root user. You would think I would be able to do anything that I want. And as the user, I can, but my application, AA test, when run as I did here, and and it's assuming the root user's capabilities because I ran it, currently is able to perform these operations. But let's do a little bit of hacking here. Let's say that we are a hacker and we found a vulnerability in this application, and we want to come in and we want to change the name of the file that's being written to test file 123. Again, something that's outside of what the application was originally designed to do. So now let's go run our script again, and let's see if it can create the file. Oh, it can't. The file creation has been blocked by AppArmor. So even though it's running as root doing it, the application itself cannot be used to do something beyond what it was originally built to do. Now, as a user, root, I can certainly touch a file called data/test file 123.txt, right? I can do that successfully as the root user, but the application cannot. So that application cannot be used from an exploit perspective to perform operations, even though it's running as root user. So let me clear that file. And then let's go back and edit our file one more time. Let's put back the changes to original, but let's just go to the bottom and let's try in a different directory. We'll just do it we'll do it in root's home directory because that's where we're running this from. Let's just try to touch a brand new file, 123.txt, and let's try to copy a file like /user usr /bin/zipper to this current directory, right? Just something else that, we're trying to hack the application. We're trying to get it to do something that it wasn't built to do originally. So we've modified that. We'll come back in here. We'll run AA test. Now, the first part of our script should work fine because we're back to normal. We're creating the file with the appropriate name. We should be able to remove it with the appropriate name. The wget should run just fine. But then those two little extra things at the bottom, yep, they're not going to be allowed because permissions denied, because that file wasn't part of the original wizard. Oh, I'm sorry, the original profile that the wizard created. And I'm not able to copy the file even though I, as root, have full access to my directory. This application does not. So that kind of gives you an example of how AppArmor interacts with, the server and protecting it based on the profile that is created and managed by AppArmor. So I've created the slide here, and at the top I have a link that I would highly recommend you taking a look at. And what it does is it goes through a more extensive profile, section by section and piece by piece, explaining what each of these things do, what are they there for, and what some of your options may be. So it helps you get to know what these profiles look like a little bit better. So take a look at that link. Highly encourage you to look at that just to get a little bit more familiar with the different aspects of the profile and what customizations you might want to do. Now, here are some of those common permissions: R for read, as I mentioned and pointed out, W for write, K for lock, L for link. So there's a lot of different options here. Very well documented. You can find lots of different examples online. So I encourage you to go take a look at those. But a couple more things I wanted to bring up. First, the AppArmor profiles are stored in AppArmor D /Etsy/AppArmor D, at least on my SUSE Linux enterprise server systems. There may be other directories for other distributions, so I would recommend taking a look under USR/share/AppArmor. Maybe they would be underneath there. But if you have let's say you've downloaded a profile or you've modified one by hand, you might or you will want to use the AppArmor parser utility with either the -A or -R parameter and to either reload a particular profile or to add a profile that didn't exist yet to the server. You could also use the -R to remove a profile in the event that you're trying to troubleshoot an application that doesn't seem to be working properly and you want to get AppArmor out of the way and just try to simplify things. That's certainly one way to do it. And then lastly, there's the AA teardown, which completely removes all profiles and everything from AppArmor off of the server, at least from memory's sake, so that you can troubleshoot and test a few things. So what about container support? In this new world of application delivery, which is a little different than sort of the monolithic style, like my script that runs on the server like that, how does AppArmor apply there? And AppArmor does have an application here. The dynamic changes because of the environment in which these containers run, primarily Kubernetes environments these days. But the important things to note is that, first of all, you're usually dealing with a cluster, and because the pods, which are the applications, can run on different nodes of the cluster, then you're going to need to copy those application profiles to all the nodes in the cluster. So that's step number one. Every node needs to have a copy of all the profiles. But each pod in and of itself becomes sort of its own sort of execution sphere. It's not a server in and of itself, but it is its own execution environment. And so to really get AppArmor to apply to a particular pod, you need to make sure that when that pod is loaded, that the appropriate AppArmor profile is loaded with it. And since all those pods are what we call ephemeral, every time a pod moves from one node to the next, meaning it existed, it terminates and shows up on the next node. If we were to try to copy a particular profile inside of a pod, like we kind of did for the nodes, we would lose all of that as soon as that pod terminates, because everything would go away and it would be relaunched on the new node. That's why we need to make sure that the container itself, or that the pod, references the appropriate AppArmor profile when it's launched at launch time. And we do that by modifying the manifest. So it's quite easy to do. You just go into the manifest for that particular pod and you make sure that this annotation section is there. And then you specify this long line here telling it which profile to load at pod launch time. And there are several methodologies out there to get these profiles copied to all the different nodes in your cluster. You could certainly leverage some configuration management tools. Our SUSE Manager product, leveraging Salt. You could do it with Ansible and some other tools. A couple of different ways of getting those profiles distributed. But once they're distributed to each of those nodes, then you can leverage this annotation section and a pod manifest to make sure that when that pod is launched, that particular AppArmor profile is loaded with it. Also, probably didn't know this. One of our most favorite commands is the PS command, so that we can look at the different services on our particular servers. But did you know that if you simply add a capital Z to the end of whatever the PS command options that you use, you will get to see a little bit of AppArmor information. So let me pull up one of my terminal prompts here again. I'm going to clear my screen. And if I run a PS, if I just do a -A, I will get a listing here. Nothing about AppArmor yet. But if I simply add the capital Z to that, you'll notice that I've got a new column here. And under it, I've got, for each one of my entries, I have, and most of mine are unconfined. And remember when we saw, we haven't looked at this yet. We looked at the AppArmor status command to see all the profiles that are loaded. But again, that doesn't mean that you're actually running a particular process. That just means that the profile's there. Here, I'm taking a look at all my running processes, and you'll notice that all of them, majority of them, are running in an unconfined state. So they're running without any restrictions, except the one we called out earlier, the NSCD, that's running in an enforced mode by a profile in AppArmor. So the PS command has some tie-ins to AppArmor, and a great way to take a look at and see exactly which profile or which applications and processes are being enforced by a particular AppArmor profile. So that's it for my session. I want to thank you for taking a look at AppArmor. Again, AppArmor is included in your SUSE Enterprise Server subscription. So there's nothing extra there. From a cost perspective, it's included. It's loaded. You just need to apply it to your workload, and off you go. So thank you for coming to SUSECON Digital 2021, and we will see you next year.